Hey guys, so here what we're going to be doing is we're going to be looking at solving some very simple trig equations. So for all of these trig equations, we would like to find x if um, x is between 0 and 2 pi. Okay, so we will be solving in radians. So for the first example, we want to answer when is sine of x equal to 1/2? So I always like to have my little table here. You can also have your special right triangles. I just think it's nice to have like this little table generated. So when is sine of x equal to 1/2? Well, right here at pi over 6. So that's your answer and you're done. Ha, just kidding. Okay, because if you actually think about the sine curve between 0 and 2 pi, it is equal to 1/2 in two positions, right? So we got that first one. We know that sine of x is equal, oopsies, look at what I wrote, pi over 2, or 1/2. We know that sine of x is equal to 1/2 when x is pi over 6, okay? So that's this first slot, pi over 6. But now I also need this other spot. So we know this is 6 pi over 6, and since we're counting in increments of 6, we would go back one to get 5 pi over 6, which would be our final answers between 0 and 2 pi. The other way you can do it, instead of thinking about it on the sine curve, it's common that people tend to think about it on the unit circle. So if we're looking at anteaters slurping tiny creatures, sine here is positive, which means my solutions are going to be in quadrant 1 and 2 because that's where sine is positive. We have here is 0. This is pi, but because we know we're counting in increments of 6 pi, or of pi over 6, this guy would be 6 pi over 6. So again, we would get our answer of pi over 6 in quadrant 1, and then we would be one increment back, or 5 pi over 6 in quadrant 2. Okay, and so then that's it. Shifting down to this guy, sine of x equals -1/2, it's a similar process, except for now, what I'm looking for is when is sine of x equal to -1/2, okay? So again, we know that we're going to have two solutions. Um, what I'll do is I'll look at my table and look up sine, when is sine equal to 1/2? And so that's at pi over 6. So based on the cyclic nature of the sine curve, this increment out is equivalent, and it's obviously mine is not draw to scale, as like this increment, right? So one answer will be 1 past pi. So if I label this 6 pi over 6, one answer is going to be in quadrant 3. 7 pi over 6. Okay, because I want negative. The other spot, sine is negative, is in quadrant 4. And so this is really 12 pi over 6, or 2 pi. So I have to go all the way over, but one increment beforehand. So then that would be 11 pi over 6. So I'm showing you both ways of looking at, say, the graph and the unit circle to get these values. Um, you could just, like, and the more you do these, the easier it'll be, and you'll just become more fluent, and you won't need to really look at the graph. You could just kind of get it. What you can either imagine the unit circle, or it just kind of becomes second nature. All right. Last but not least, we've got this example. I'm going to bring this little table with us here. So let me pick them up and move them over here. Okay, so this last example, I would consider solving this the same way I would say, hey, can you solve 2x equals 1? Oh, I'm going to change this 1 to a 2. And so to solve, say, 2x equals 2, you would divide both sides by 2 and get x alone. The same thing is going to be true for here. You want to get that trig function alone, okay? So I will divide both sides by 2, so I'm left with tangent of x equals 1. And so now I need to figure out, okay, when will tangent actually equal 1? So on my tangent here, I'll go out, and I see that tangent is equal to 1 at pi over 4. So pi over 4 will be one of my answers. But that is not the only spot on the unit circle where tangent is positive. So tangent is positive in quadrant 1, and it's also positive in quadrant 3. So because I'm thinking in terms of pi over 4, I've got 0, pi, which is really 4 pi over 4. And I don't have to loop all the way around because I only want to go to quadrant 3. So one increment more than 4 pi over 4 would be 5 pi over 4. And I'm done. Yay!